Dr. Ravi Kumar MG from the School of Electronics and Communication Engineering, Reva University, Bangalore. He's a PhD holder from Reva University itself and MTech in signal processing from VTU, Belgaum. Dr. Ravi Kumar has many research publications in many reputed and indexed national and international journals and conferences. He has published 15 papers in peer-reviewed national and international journals, 5 papers in reputed national and international conferences, and also he is involved in research which covers various sorts of underwater acoustic communication and signal processing, such as channel modeling, channel estimation, channel coding, MIMO, OFDM design, and image processing, etc. He has worked for 2 years for the successful completion of the research project funded by NRB, DRDO, and is presently working for the Respond Research Project funded by the Indian Space Research Organization. He is a reviewer of IEEE transactions, IEEE Access Journal, and various other reputed journals and conferences. His research areas include underwater acoustic communication, signal processing, wireless communication and networks, network function virtualization, etc. With this brief information, I would like to invite Dr. Ravi Kumar MG to handle the present session. Thank you.
Yeah, thank you, sir. Thank you for the nice introduction. Before starting, good afternoon, all of you. I hope
Yes,
my
sir.
voice is
Good
audible.
afternoon.
Yes, sir.
Yeah, very good afternoon.
Yes, please proceed.
Yeah, okay, sir. Okay. So, thank you for the introduction, and it's my honor to share with the ideas, or I can say some of the information which relates to introduction to the network function virtualization, which is my research area. So today we are going to discuss a few things about the NFV, and also before starting, I will just mention, so whatever the presentation I'm going to present today, so it will be in the perspective of a researcher, because this field, whatever we are working on this, so we could see a very minimum, the in the 2-3 years, there are a drastic change in this particular field. But previously, if we consider before 2011 and 12, so this area or this field is very rarely we can see. So that's why, so with the perception of the researcher or a beginner, if we see, so then it will be helpful, or it may lead to some innovative ideas or with research problems. So it may be helpful for you as an audience also. So with this, I can proceed. So the agenda for today's presentation will be the motivation for this particular NFV. So in that we can see the trends in IT and also the telecom challenges. What are the challenges we are facing, and the solutions for this telecom industries, which will be very popular, or we can say which is very revolution through the help of cloud native networks. So for this, the technologies, if we consider as a cloud native networks, so SDN is a major thing, a major technology we can say. Then NFV and hypervisor and so on. So in this particular, I'm going to concentrate mainly on the NFV and also a brief introduction about the SDN, because without SDN, we can't say, or we can't go for the NFV directly. So with the brief introduction of the SDN, we can go for, or we can see about the network function virtualization. And in that, we can see the vision of NFV and approaches, and what are the benefits and the promises it is going to do with the industries or telecom, especially in telecom. So, and also the NFV requirements and challenges, or I can say the what are the limitations it is facing, even though the field is in the revolution or in the booming era. but still it is facing some issues. So you can see what and all the challenges also it is facing. And also most importantly, the network function virtualization architecture. The architecture is the main building block in this particular process, or I can say this field NFV. And also the orchestration and the network slicing. So this we can consider as a use cases of NFV, and with the help of this, many I can say many applications have developed, and and it leads to the many research problems also if you understand the basics of orchestration and the slicing itself. So this will be the agenda for today's presentation. And coming to the motivation, so as we were using, or as we are now also we are using many devices, physical devices, I can say. So whatever the requirements with respect to the, or in the perception of the users, if you are considering the whatever the physical devices or the infrastructure we are having now, so that is not sufficient. Whatever it is the available physical infrastructure, so that is not, and also the physical devices, it may be storage device and all, so it is not sufficient. Yeah. So now, so there are some whatever we are going to expose or explore in terms of the network function virtualization. So as a background of this, or as a motivation, if we look into that, so the complex carrier network is the main thing. So that will be having with a large variety of proprietary nodes and hardware appliances, because whatever, for example, if you want to build any network and all, so it will be usually it will be consisting many number of or variety of hardware devices, and it leads to many parameters like the cost also, the time, and it also complexity also. It all depends on the applications or the requirement of the users. And for example, if you want to build a network which will be for a particular application or the particular reasons based on the demand of the user. So if you want to launch also, so that may be difficult to launch. So due to the reasons of the, like maybe space or power also to accommodate, and also it requires just another variety of box, because since it is a physical device, it may require the box or any other extra physical device. And whatever the devices we are going to have for to build a particular network or critical network, so that have to be integrated. So again, that leads to the time consumption and the cost. So all these issues, I can say, or all these parameters it will be going to face. And also, if the hardware network, I can say, or the physical hardware, physical devices, if you are combining and integrating, so that may leads to the complexity also. So, and the operation wise, if you see, the operation is expensive, and also it rapidly reach to the main objective should be whenever we are operating some hardware devices or any physical network, so the rapidly it should reach to the end of the life, means the end users. And also due to the existing procured design or integrated deploy cycle, so that will be difficult if we are going for only for the hardware or physical devices. So since we are having or we are facing all these issues or limitation, so the better solution or the solution if we see, so for this, so the softwareization of this particular network will be the solution. So in order to softwareize the network, whether the network may be the small network or the large network, depending on the user or depending on the equipment or depending on the requirement of the user, but still softwareization is the better solution. That way, if we just observe as per the present scenario, the softwareization will be the better solution, and that will be the future also. And before realization of the network, the function of the whatever the functions of the particular network, if we consider, so we can see what will be the trends and what will be the challenges also along with that. So the trends, if we consider, the high performance industry standards serves shipped in very high volume. So the industry standard we have to maintain, and we have to look onto the industry standards also. That will be the trend. That will be the trends, and also the convergence in of computing, storage, and networks. So since the applications are evolving and applications are taking a different versions based on the users or based on the requirement, and and it all depending on the evolution related to the technology, we can say. Then, and all these conversions of the computing, or it may be storage or networks, if you see the network virtualization technologies that abstract underlying hardware aiding elastically, and also the scalability, and also the flexibility we have to see in any network operation. If you see the flexibility also, we should take care. And also one more thing, the automation. So if you are preferring only the traditional devices or traditional hardware network, if you are looking, or if you are observing, so the automation we can't perform effectively with respect to physical hardware. So if it is softwareization or software defined or a software based network, then the automation is easy. So that is also one of the main, or I can say the one of the biggest advantage by the softwareization. So for this, the trends, as a trend, the software defined networking will be the better solution. And also to replace the hardware devices or storage devices, it may be RAM or it may be any hardware devices. If you consider the cloud services or cloud networks will be the solutions. So, and the mobility also. So whatever the networks are we are designing or we are going to implement, so we have to see about the mobility also. So if it is a hardware network, or if it is a physical network or the software network, so we have to see the mobility also. And with these trends of the today's, or like the present scenario, if we see the challenges also, we have to see the challenges also, we have to seriously observe about the challenges also. So in the physical network, or the, or whatever the hardware networks, if you are going for, so it will be usually, it will be causing the expensive expense, in the sense it leads to the more cost. So the capital investment with the current trends, that will be more, that will be huge also. Then the network operators face the different one, the increasing the disparity between the revenues also. And also it leads to the complexity and the lack of flexibility with respect to the hardware network. Whatever the hardware network is, so it leads to the lack of flexibility and also agility. The agility also we have to look into that. So it cannot move network resources where and when it is needed. If it is hardware, for example, in the laboratory, if I am doing something and if I am trying to implement with the help of hardware, so it won't be a much agility, or you can't move, or as and when we required, so we can't move, or the movability or the flexibility will be not there, as it will be there, but completely or not much it will be there with respect to the hardware network. So if it is a software or software based network, then it will be easy to move from one place to other place, or I can say, or from one network resources to another network resource, or where and when if required or needed, at that time it is easy to operate also. Then launching a new services is difficult and it takes too long. For example, if you want to some hardware we have implemented, hardware network or physical network we have implemented, and if you are interfacing, or for example that hardware and whatever the network we implemented, if you want to add something else into that, so again it requires more time, more cost, and more the complexity also. For example, if you want one, at least one character or one special feature, if you want to add to that network, so again it leads and it will be difficult in general. But if it is the software based or software defined networks, so then it will be easy to modify or add or remove any the feature, or any feature if you want, or if you don't want, so we can modify or we can remove easily. So that flexibility with respect to software based networks. So as we seen the difficulties with respect to the physical network or hardware network, so we can think about the replacement of the hardware So now if not completely, at least more than 90% or 80% we can replace. So whatever the uh, in the network, whatever the hardware functions are particularly it is performing, so that can be softwareized. So, and we have to think about the advantages of the softwareize also. If we softwareize everything, so what will be the advantage and what will be the future, and what will be the whatever the consequences we are going to have. So if it is softwareized or if not, so we can think. And as I mentioned, the telecom industry basically, if we consider, so it is going through revolution with the help of the cloud native network. So nowadays, as I mentioned, so whatever the devices or storage devices, whatever we are having physically, so that may not sufficient completely. And I hope you also agree with that. That may not, almost it is not sufficient to store or to use for based on the user's requirement. So we need to go for the cloud native network. So in the cloud native network, so the technology we can see in today's session, at least two, three network, the techniques we can see at least in brief. So that will be like SDN, NFV, hypervisor. So all this we can see. And as I mentioned, the SDN, so it stands for software defined network. So in simple way, we can say the SDN, the software in the network. It is going to softwareized the network, whatever the hardware it is having in that particular network or dedicated network, it is going to softwareize. So if it is going to softwareize, we have to think what will be the advantages and what is the consequences, or in a negative way it is going to face also. That also we have to think. Then NFV and SDN, if we see with respect to operation or construction, so it will be highly complementary. And so with the help of, so if the system or if the network, if it is softwareized, then the NFV can be implemented in a better way. So even though without the help of the SDN also, we can try for the NFV or network function virtualization, but still with the help of SDN, we can build or we can implement the NFV concept or the ideology so in a better way. So because the, so whatever the network it is having already, so that is softwareized. If the network is softwareized, then the functions of the of that particular network, so we will think, or we will see in the next few this one slides. So what are the basic functions of the network we can easily softwareize and we can easily virtualize. So for this, basically, the network, in the network, whatever the hardware system or hardware devices will be there, so that is going to softwareize. So that is the basic purpose you can say of the SDN. If you see, so it is going to allow users to virtualize their hardware, whatever it may be. The hardware size may be, it may be depending on the applications or depending on the requirement. So this particular technique, the software defined network, it is going to allow every users to virtualize their hardware. And we have to think as well. So if we are going to virtualize, what will be the advantage? What will be the limitations also? And this particular SDN techniques attempts to build a computer network by separating into usually or in general two segments. So one will be the control plane and another one will be the data plane. So usually this control plane will be generally used to manage the configurations of the devices connected to the SDN network on a remote access basis. So in a particular laboratory or anywhere, if you are considering, or if you want to implement that particular SDN, so we have to think about the control plane with respect to architecture control plane and the data plane also. So the data plane will be the responsible for forwarding the traffic to its final destination. So the control plane is having its own responsibility, and also the data plane is also having its own responsibility. So I can say as a summary of this SDN, so it is going to the whatever the hardware it is having in the particular network and all. So this technique is going to softwareize the network. So in order to softwareize the network, again, it will be having, or it will be facing some issues or the problems or difficulties, I can say, but still there are some other solutions also in order to softwareize the network effectively. So With this brief introduction about the SDN, so in today's session we can, as per the title, we can see at least in detail about the network function virtualization. In this NFV, if we consider as an example of this particularly, if we consider the NFV, it means to make a network more flexible and simple by minimizing dependence on hardware constraints. So if you see this sentence, so this is also using, or this is also more dependent on the software itself, not hardware. So as SDN is going to softwareize the hardwares, and this is also softwareizing the network, and also it is mainly concentrating on the functions of the network. That is the network function. So the network functions may be routing, firewalls, or gateways, or any load balancers if you consider. So whatever the functions of that particular, or in general the networks are there, so that will be going to virtualize. And in this NFE, basically it is having, or it consists of three main stages. The first one is softwareization. Softwareization is a basic thing in the NFE concept. If you want to implement NFE concept, we need to think, or we need to be very thorough in the first stage, that is the softwareization. When all the network, when all the components in that network, or all the components, or all the devices are already transferred, or already softwareized, then the second stage will be easy. Then the second stage is virtualization. So if the hardware thing or the physical device is softwareized, then whatever the functions of that particular hardware, so we can think about the virtualization of that particular, or that dedicated function. So it may be routing, or router. If you are softwareizing, then the function of that particular routing, so we can virtualize. So if that the as a overall overview, if I want to say, if we want to use one particular router at a time, so hardly we can, in general I am telling, in general, so 10 members, if you are considering 10 members can easily use the particular router. So the router configuration, it may be vary, but in general, if I am considering, so hardly 10 members can use effectively. So if you want to increase the number of users, the efficiency with respect to the usage, if you want to increase at that time. So if you are preferring only hardware, so we can't increase, we can't improve the efficiency. So at the time, if we are virtualizing, if we are virtualizing that particular function, the router function itself, that is the routing, if we are virtualizing it, then it can be used by n number of users. It can be used by the n number of users. You just imagine, with the simple example of router or routing the function, so it can be used by many people. Again, it leads to many complexities also, because if the routing or the function, if it is virtualized completely, and it can be used, as I mentioned, it can be used by n number of users. If I say 100 members, when 100 members are trying to use the same function at the time, again it leads to the complexity. So which one can use first or next, and how much data the first person can use or the second person can use. Again, the slicing or the orchestration concepts will come next to solve these problems, but still, as an overview, so it will be more helpful compared to the hardware thing, hardware or physical storage network, if we consider. And in this particularly, if we see the traditional network model or appliance approach, if you see, so whatever it is seen in the left side, so these are the different devices which can be used for the particular functions, So if you see the DPI, the deep curve packet inspection, so if you see, and the BRAS, the border router access server, and similarly the gateways and the router, and also NAT, the firewall, and the session border control, if you are seeing, so these are dedicated for the particular function only. And at the time it is dedicated, or it can be used only by the particular users, not in general, or not many or multiple usage may not be possible at a time in many situations. So if this appliance approach or the traditional network model, if you want to build or if you want to transform to the virtualized network model, so this is also, so this will be the simple way or the simple architecture of the NFV. So whatever the bottom stage is there, the portion, this one, this will be the standard high volume servers. This is the first stage, so we can say, and whatever the functions by the done by the particular the dedicated hardware devices, so that is going to here virtualize. So this we can see the virtual appliances and how these physical resources are going to become, or physical or hardware resources are going to become the virtual resources or virtual mechanisms. So that is with the help of hypervisors also. The hypervisors is the a tool which can be helpful in order to transfer or in order to make the virtual physical resources into the virtual resources. If it is virtual resource, many persons or many people can use whenever they require. So this is the simple transformation from the traditional network model to the virtualized network model. So here, if you see, so it looks like simple, but the things or whatever the procedures or limitations or the difficulties in order to transform from this traditional model to the virtualized network model, it leads to many difficulties. So we can see next, and the target of the particular in this particular scenario, if you see the target of the network function, so this picture illustrating the target. So what will be our vision, I can say. So the target of the classical network appliance approach, it should be the network virtualization approach. So in the network virtualization approach, if you see, the physical infrastructure is going to be the virtual infrastructure. The network function virtualization will be helpful or will be implying in a better way in order to make this network effective way, and which will be helpful for the many users. And in this, if you see the physical devices which will be used for the particular or for the dedicated functions, and here you see whatever the physical infrastructure will be there, so that will be transferring or that will be created as the virtual resources or infrastructure, that is the NFVI, network function virtualization infrastructure. That is the fundamental thing, because when the hardware resources is converted as the virtual resources, then only the virtualization can happen. Otherwise it is not possible completely. So the here the second stage, and here the standard high volume servers will be useful, will be used, and the storage devices also. The storage devices, if you see here, for the with respect to the, or if we compare with the physical network or hardware, physical hardware, if we consider, so it needs it leads to the simplicity, I can say. And here this will be the final thing which is going to become as the end product at the end user, so the independent software. So here many virtual appliances will be employing here. The virtual appliances in the sense whatever here we are using or we are showing, so the same thing here also we are showing, but in terms of virtual. And here there are some parameter which will be really helpful in order to transfer from real or physical to the virtual, or the physical infrastructure to the virtual infrastructure, and also with respect to the operation and the management. So we can see the exact configuration or architecture of the NFV, but in general if you see, so there are some parameter like orchestration and automation and network slicing. So all these things will be helpful in order to give or in order to provide a better solution. And coming to the network function virtualization, if we want to know more about this, as I mentioned, this is consisting of three parts: as a softwareization, then virtualization, and the orchestration and the management. Orchestration and the automation also it involves. Then it is about implementing the network functions in the software. As SDN defines the software, the whatever the hardware it is there, it is going to softwareize, but the network function virtualize definition, if you see, so that is complementary to SDN. So whatever the software it is there, so it will be going to deploy in the network itself. So whatever the functions of the particular network, if we consider, so that is going to virtualize, not, well, it is not virtualizing the hardware devices initially. So first the hardware is, so the infrastructure will be converted as the virtual infrastructure. Then the functions of that particular it is considering, then the function will be going to virtualize. And one more thing, whatever the NFE, so as per the literature survey, if you see, so almost 2009, 2010, and 11, if you see, based on the NFV or STN, the work was very less. The work done, whatever the work done by the researchers. So after 2011 or 12, so this work based on this, so it is almost the drastic change we can see, and many of the applications evolved based on the technologies. So it, and also the idea, whatever the network implemented, like the 4G and 5G and all. So based on that also, the many work done by the researchers with the help of our network function virtualization. And especially before popularizing this NFA, the ETSI, the European Telecommunication Standard Institute, actually this made the NFE more popular by defining its particular specifications, and also it defines some configurations and standards with respect to NFV. So base, and also in 2011 and 12, many almost 10 to 12 Taiwan companies have combined and they formed the standards. They formed many configurations with respect to NFV. So after that, so many work done so far with, in the field of network function virtualization. So if you see other countries and all, so already 5G and 6G already 5G implemented, and they are already trying for 6G, and with that also it is having many advantages. And also one more the component like automation, if you consider everything almost in our daily life or in any application, if you see, everything is going to automate now. So in order to automate in a effective way or in a better way with respect that too in the software field or software network, so all these things will be very much required. And also it supports multi-versioning and multi-tenancy of the network functions. As I mentioned, one particular function or one particular function of the particular this one hardware that can be used, that can be used by the many users. That is the multi-tenancy. That facility we can see in the NFV. And also since it can be, the multi-functions can be run by the a single server. So if you are designing or implementing the server in a effective way, so the multiple functions can be run at a time. So if the multiple functions are running on a single server, you just imagine how much the cost it is reducing and how much time also it is saving. So the cost and time, you can see many parameter in a better, in a positive way we can observe here. But the thing is, so we have to implement the NFV in a proper way. So the implementation and the execution of the NFV is more complicated, we can say, but still, so if you work on that and if you want to get the better output, so we have to take the difficulties and we have to work on that. And also it facilitates innovation towards new network functions and services that are only practical in a pure software network environment. Whatever the thing or whatever the functions are which is already or we can already have with the help of the physical devices. So the same functions if you want to have, and the same the outcome in a better way, in a better way by minimizing the limitations in the hardware infrastructure. So we can go for the NFE, and it also facilitates with the innovation. And also the aim of the NFE, if you see, ultimately it transfers the way network operators architect and operates their network. But change can be incremental. So it is depending on the requirements and the demands by the user, and how we are implementing the building of the NFV also. So as the benefits, if you see, it reduced equipment cost, and also it will be increasing the speed of time to market also. So why? Because so it is almost replacing and almost minimizing the dependency on the hardware. So if the dependency of with respect on the hardware, if it is reducing, definitely it leads to many advantages also. And that's why, and also it will be helpful in order to automate the things in a better way. So whatever the internet of things and all it is there, so it can be implemented in a better way if the network, or if the whatever the softwareization in that particular network, if it should be implemented in a proper way. Not only in the internet of things, so if you consider the internet of underwater things also, in that field also, if SDN and NFV are the main solution, and are the better solution, I can say. But in the internet of underwater things, the NFV and SDN not yet implemented in a complete manner, but still, so that will be the feature. So once it is implemented in that particular the whatever in this particular domain, so then it can be moved to the after IoT, so then it can be implemented in the IoUT also. So as with the benefits and the promises of a NFV, so we can look upon the need also. So why we need NFV? So just I will be briefing about the needs, the importance of the NFV. So virtualization. So if you want to virtualize any network and so we can go for the NFV or SDN, and also orchestration. So the orchestration in a simple way. So if there are 100 functions or 100 functions as a multifunctional it is running, so which function should run first, or which user should use first? So all this scheduling, I can say in simple way, the scheduling. The orchestration can manages in a sense with respect to operation or with respect to the other parameters also. Then programmable. So if it is softwareized or softwareization, if the network, then the programmable is easy. If it is programmable, then the operation can be minimized, or it can be done in a better way if you want to get effective output. Then the dynamic scaling also, it should be able to change the size, quantity, and the scalability is very important. And NFV mainly it gives or it provides the scalability. And also whatever we are seeing orchestration or programmable or scaling, definitely it will be helpful directly or indirectly for the purpose of automation. So if the automation is happening or when with better technologies, then so what will be the advantages? So if the things are getting automated, then visibility, and the whatever the monitoring or whatever the operations are performing at a time, or multi performance, we can, if we see, then the monitor resources and the connectivity, if it is physical, then the connection the connectivity can be the monitoring of the connectivity, so that is different. But if it is completely virtual, then the monitoring will be and it will be in the other way. And one more thing, if you see the structure or architecture of that particular NFA, then it is logically connected in a better way compared to the hardware. So in the hardware, if you are connecting 100 wires or 100 cables, if you are connecting at in a same network and all, so there, so some of the errors we can see. But if it is virtual, then such errors we can easily minimize. And the performance also, so obviously if it is programmable in a better way, and if it is monitoring and it is managing like in this with the help of orchestration in a better way, then definitely the performance of that particular network, that will be good. And also one more important thing is that is multi-tenancy. So this is not possible completely if you go for the physical devices. But if we are going for the SDN or the NFE, the multi-tenancy will be the better facility we can see. Then the service integration. So many services can be integrated in a better way, and that can be used for the better improvement of that particular network based on the user demands. And also the openness, it is full choice of the modular plugins also. So due with these advantages, definitely, so this will give the answer for why we need or why we want NFV. So if you are not going for the NFV or SDA, so these facilities we are not able to get. So if you want to get all this facility, so then the solution is we have to go for the NFV. And if you think these facilities are whatever the advantages significance I mentioned, so if we just correlate to the particular or the real-time applications, then you can easily understand the significance or importance of NFV or STL. And it may, in all these, whatever the points here mentioned here, so if we researched or if we do survey or literature survey on this, definitely it leads again many research problems also, because in the orchestration itself, orchestration or network slicing or automation and multi-tenancy also, the managing the multi-tenancy is difficult task in the NFV. So again, it leads to many research problems. Then the use cases, if you see, of the NFV, network virtualization, and one more thing in the virtualization, not only it is network virtualization. So if it is server, so then server virtualization also, and if it is any hardware, it is a so that hardware virtualization, and also the service. For example, if you want to get any service of that particular network, so then if we are virtualizing, that also one of the type of virtualization, not only network. So whatever the networks are, whatever we are experiencing now, so that may virtualize in the future days. Whatever, for example, we are using the SIM cards and all nowadays, Airtel or any other SIM cards we are using as physical component, so that may virtualize in next or in future, it may virtualize. Then mobile edge computing. So the mobile edge computing itself a big, uh, I can say the big topic, because so with the help with the mobile edge computing, lot of designs are implementation, lot of work. So still it is going on in order to design a network in a better way, and also the orchestration engines, as I mentioned, the orchestration, because this is the main thing, a main part I can say in the NFV process. So if the orchestration is good, then the overall performance or overall operations of that particular network, that will be good. Then video analytics and security also, and we have to think about the security. As I mentioned, so if the one particular function is can be utilized by the 10 members, so when that all 10 members are using, so we have to think about the security also. So simply we can't provide or we can't allow all 10 users to use that particular function. So we have to think about the security and the network slicing. At the same time, if all the 10 members are using or 100 members are trying to use the same network, the layers of the network should be sliced and should be allocated. The allocation is also very important thing in order to improve the efficiency of that particular network. So the network slicing will be the solution in order to provide better facilities for the user. And coming to the NFV architecture, so this NFV architecture will be having mainly the three concepts or three parameters, usually building blocks I can say. One is network function virtualization infrastructure, NFVI. Then virtual network functions, network function virtualization will be different. The meaning, if you understand the virtual network functions, whatever the functions are there of that particular network, so we are just going to virtualize that. Virtual network functions will be responsible in order to virtualize that particular function. So here the software applications that deliver specific network functions such as routing, security, mobile core, and IP, then multimedia subsystems, video, all these things will be coming under virtual network function. So this second part is responsible to take care of all these things. And one more important thing is that is the management, automation, and network orchestration. So if you see this terminology itself, So these are the responsible functions. So this component who is taking care of all these terminologies, or I can say all these process, will be the very important thing in that particular process. So this is a traditional building, or the network model, we can say the specialized appliances purpose build. So it is having some routers, the CZNR, DNS, PCRF, or OCS, MME, all these things. So, and it is connected with the switch. So if you see, this is the traditional, I can say the traditional model. So this particular model, if you want to use by the 100 members or 100 people, if they want to use at a time, this is difficult. And if the 100 members wanted to use, then the solution is we have to increase the license. We have to increase the license, and the requirement of the specification should be changed. The specification of the particular PGW or MME or OCS or PCRF, all these things should be changed. The modification in that particular network will be difficult compared to the softwareized network. So this is the generalized or the traditional one. And this, if you see, this will be the network function virtualization. So here, whatever the hardware it is having in the traditional, the generic hardware, but the thing is, whatever the functions of that particular network, all these are going to virtualize. So the features of this particular, if you consider the purpose built to hardware to the generic hardware, then app running on the software, whatever the app or the applications it is running, so it is running on the software, not directly on the hardware. So if the app, a particular app or function is running on the software, then it can be virtualized and it can be used by the other user also. And the separation of network function and capacity, and easy capacity scale up and down. So the scalability can be done in a better way in the NFV compared to the physical infrastructure or the traditional network. And also the virtual machines are building blocks of this particular NFV. So here, this is the general block architecture of the NFV. So if you see here, the fundamental thing, that is the hardware resources. The hardware resources, like for the purpose of compute, storage, and network. If you see, these are the general functions of the hardware resources. And here, if you want to transfer, or if you want to transform, or if you want to create the virtual infrastructure, this is the physical infrastructure, but this is the virtual infrastructure. So if you want to create this, so there should be one virtualization layer, and here the component helpful, or which is responsible to convert this hardware to virtual resources. So here, whatever the compute or the whatever the three general functions we have taken, so that I have mentioned here: virtual compute and virtual storage and virtual network. So once it is transferred or transformed or created as network function virtualized infrastructure, then the next thing is that should be the function should be virtualized. The function should be virtualized. For that, the virtual machines are responsible in order to make, or in order to create the function as virtualized function. So if the function is completely virtualized, then the function can be used by other users also. But for all the whatever the component or whatever the process are happening at the left side, so all these functions or all these process controlled by the NFV, management, automation, and orchestration. So this is the fundamental block which is responsible for the overall monitoring or overall management of the particular operation. So this will take care about all the operations in the NFV. So if it is the decision of the allocation, for the particular application, based on the requirement and all, All these things the NFV or the Mano will take care. And if you see this, the network NFV, the cloud network. So as you all most aware that, so whatever the physical device or the storage devices that is not suitable, that's why we are preferring the cloud network. So cloud, so in this, the cloud LTE network, if you see whatever the functions, if you see in general, SMSC or MSC or HLR or SGSN or GSGSN, all these are the particular functions of the software network. So these network are you going to utilize, are going to occupy the cloud. So here the virtual machines are taking the whatever the functions here, they're taking it, and it is providing to the user. And this I can say the generic hardware virtual machines here, whatever it is there for the purpose of compute, storage and network. So this is in general, but if you want to take, or if you want to consider for any other particular or critical applications, at that time the hardware resources may change. So this is not constant hardware resources for the NFV. It is up to the user, how users are how users want to implement that particular NFV network. So in that way they can utilize. And here each application is running on one or multiple virtual machines. So if the application is small and it requires very less number of components and all, at that time whatever the functions, it may be n number of functions, so the n number of applications or functions can be run in a single server. So if the application is more, or if the application is large or huge, at that time we need to go for the multiple virtual machines. But the thing is, whatever the functions are softwareized, that can be that are utilizing in a better way by the VM. And here the different layers. So here we can see the first stage, whatever I have mentioned in the previous black diagram, the physical hardware, this one the stage here, and the network purpose. So these are the hardware devices, but with this here the virtualization layer should be there, because that will be that will be transforming, or that will be uh, again, it is replacing with the virtual storage devices for the memory and virtual compute or virtual network. So again, if you want to go for, or if you want to know about virtual network itself, again, it leads to the many parameters which are going to helpful in order to make like a VNF or any EM3 or EM. This, since we are considering only three, so that's why we are mentioning 1, 2, 3 like this. But here the thing is, the virtual, whatever the physical hardware here it is, so it is transformed, or it is going to softwareize and also virtualize. So here the OSS and BSS, so these are all the it is related with the management. It is related with the management, means that is the orchestration. So this is the open support system, and this is the business support system. Open support system is related to the it will take care about the any fault management or any error occurred in the NFE and or in the process. So this system will be taking care, and also for any billing application, billing related things or revenue generation, all these things. So the business support system will take care. So this is, as I mentioned here, so the services, VNF and infra description will be taken care by the OSS or BSS. And here the orchestration, VNF manager and VIM, virtualized infrastructure manager, these three blocks are responsible in order to take care of the complete or overall functions. And NFVI, if you consider this infrastructure, this will manage the physical part in NFV. Whatever the physical part, it may be related to compute or memory or network. So this particular part or this particular NFVI will take care of that. And as I mentioned earlier, hypervisor, so it is responsible for abstracting physical resources into virtual resources. So whatever the physical resources are there initially, so that is going to become virtual resources. In the second stage, that is the thing happened here. And also this VIM is taking care about the management and control for NFVI. So this is controlled or managing by the VIM. virtualized infrastructure manager, and also it manages reports and events with respect to the process done by this particular block. So this particular block is concentrating on this first stage, and in the next, the second stage, if you consider that is the VNF, virtualization, virtual network functions. So here particular functions or particular functions of the network is considered, then it is going to softwareize. Then here a VNF is the basic block in NFA architecture. Example, virtual IMS, we virtual MME, virtual MSC, virtual switch, or router. Anything if you consider. These are all the example we have mentioned here. And this element management of this particular VNF, that is taken care by the VNF manager itself. Applications such as Linkdown, KPI, Degatran, all these things, degradation if you consider, this is done by the or managing by the VNF manager. So this is with respect to the second stage. And also VNF manager is taking care of the life cycle of the VNF's virtual network functions, setting up or down or maintaining or tearing down or not. So all these functions will be done or taken care by the VNF manager. So finally, if you see the orchestration, these orchestrator are responsible for the overall management, for overall the management of the operation or process. So it is also the key to automation of SDN and NFV, because based in for the SDN also, if we consider the orchestration or orchestrator is a more responsible thing, and it performs resource orchestration. If there are with respect to resource orchestration also, it is able to do, and also the network service orchestration. For example, if you are if you are implementing the NFV, if you are implementing the NFV with the help of 100 resources, then all the resources are virtual resources only, but still 100 resources are there. So I want to allocate, or I want to provide all the 100 resources, virtual resources, to the 100 or 50 users. So users, if you consider this, that is almost 1:2 the resources. So how I can allocate? So there are some the parameters we have to consider, or some protocols we have to adopt in order to provide or in order to allocate. But the thing is, but who is doing that allocation and all? So the orchestrator will take care of that. So, and also the network service. So if the particular virtual resource is providing 100 service, 100 network service, if we in general, if we consider as an example, so how it is going to allocate, or how it is going to uh, useful for that particular user. So it depends on how the orchestrator is managing. So not only the resource orchestration, it also network service orchestration also, it is done by the orchestrator. Then global resource management of NFVI resources. Whatever the NFVI infrastructure is there, NFV, so that is also taken care by the orchestrator. And also allocating and scaling the resources. Scaling the resources in a sense, so how exactly the user needs, and depending on the user or requirement on the, based on the requirement of the user, the scaling is done by the orchestrator. And the single orchestrator can be managing the many services, and also the many resource allocation also. So, and in orchestration, if you see, network NFV orchestration coordinates the resources and networks needed to set up cloud-based services and application. And actually, this orchestration is the automated configuration and management in general. If you want to define this, so automated configuration and management and coordination of computer systems, applications, and services. So if you want to understand, I hope you understood the meaning of the orchestration. So in a simple way, if you want to understand the idea about the orchestration, in orchestra and all, we have seen, so there are many musical components are playing at a time, but one person will be there who is taking care about when the particular musical event should be played. So all these things, one person will be managing when it is more, and whether it may be the frequency, if you consider with respect to frequency, this one, the music, when it should be more and when it should be less. So one person, that is nothing but the orchestrator. Here also in the network, that too in the softwareized network, so one person or one tool or device should be responsible in order to control or in order to manage the process. So that is nothing but orchestrator, and it is giving, or it leads to many advantages if we are good in the orchestration, not only with respect to the softwareization and all. In many applications, if we consider, we should be a good orchestrator. So in the field of academics or in the field of any industry, if we consider, so we should be very good in the orchestration. Then orchestration, it requires some parameters like service coordination and instantation, because when multiple services are providing to the users at the time, so there should be some proper coordination in the service management or service allocation also. And not only in the service allocation and in the resource allocation also, there should be proper coordination, cloned and multiple to the scale for either a single customer or many customers. So it depends on the user. Then the scaling services and also the service monitoring. So the monitoring is also very important in order to give the better facility, I can say. So for this, the Mano is responsible, and which is having actually compared to the other thing. So this will be, this particular block will be having more responsibility, because this is the fundamental thing, and this is the important block which is taking care of the all the process. And the second use case, if we consider the network slicing, as I mentioned in the briefly, so if there are many or multi users are utilizing or trying to use a particular function which is in the same layer, at that time that should be divided, that should be sliced properly. After slicing, the allocation also should be done in a proper way. So the network slicing is also an important parameter in order to give or in order to go for the better efficiency. So NFV and network slicing. So these are two concepts. I can say these are very related, and it is likely that NFV will begin to play a crucial role in this slicing, especially for 5G, because when 5G implements in India and all, so at that time, how we can utilize that particular 5G network and all. So for that, the network slicing will be the crucial part it is going to have. So this will be the simple architecture for network slicing. So this will be having infrastructure layer and also the network function layer, and finally the service layer. So all these things, again, it will be taken care by the orchestrator. So the orchestrator is responsible for all the things in the NFV process. And since each slice of the network can be referred as a network function individually, because each slice is using by the or utilizing by the particular user, so that will be we can consider as a network function itself individually. And this automatically allocate the necessary resources to each network slice at the right quality of service and also the performance level. So when it is slicing and allocating something, some layer, so at that time, it should think about the QoS and performance also. And benefits, if you see with respect to network slicing, it provides the configurable and optimize specific services. And also it adds flexibility, efficiency, and agility to the end user, because the allocation and slicing is done in a better way. So obviously it leads to all these advantages also, like flexibility, efficiency, and agility. And it also reduces the capital expenditure and operational expenditure also, if you are slicing the network properly. If you are not slicing the network and allocating to the user at the time, whatever the available network or the whatever it is there, so that may not be used properly or utilized properly by the users, and it may leads to the large amount of the expenditure also. And it improves deployment times for network services. So these are some benefits if we go for network slicing. And applications, if we see with respect to NFE, so there are some leading NFE applications we can see with respect to software defined branch or multimedia subsystems, session border control or video servers, and also the VCPE, the control delivery networks and network monitoring also. In all these applications, so the NFE concepts or NFE idea is playing the important role in order to or in order to play a very crucial role in the industry. So finally, we can conclude like the NFE may not have quite conquered the world just yet, but with the world becoming increasingly virtual and NFE, so gaining more and more momentum. So we could see in a few years of time, so we could see a day when virtual security as well as the other user cases featured on this list. Whatever we defined a particular or limited user cases now, so that may increase. So it becomes rule rather than the exception. So this is the end of the presentation. So now if you are having any questions or queries, so we can proceed.
Participants, please unmute yourself and you can ask questions. Daya ma'am, any questions? Shalini ma'am, Vijay Lakshmi ma'am. So I think there are no questions from the participants.
So if you're having any questions, you can we can see because this topic actually, so the time whatever we got, so it may not sufficient to discuss in detail, but briefly we were discussed, I hope. And this the area, so if we just look into, or if you are interested to work in this particular area, it provides many research problems for the researchers if they want to work in this particular field. And that will be the booming area, and that will be the future if you see. So this will be I hope this session helpful at least in some manner.
Thank you, sir. So on behalf of Department of Mechanical Engineering, Tkmce College of Engineering, and as a coordinator, and on behalf of participants, I sincerely thank for the session you had, and thanks for accepting our invitation. Thank you so much, sir.
Yeah, thank you so much for the opportunity given by the management. And also personally, I would like to thank Dr. Pramod sir and Dr. Riberai, so for giving the opportunity as a resource person for this particular FDP. Thank you, all of you.
So there's one question in the chat box.
Yeah.
Which is available in market for NFE, or which programming language is used for NFE?
Okay, fine. Sir, actually, the companies, if I see, if I tell, so the companies who are already implementing this particular NFE, so the VMware, the Cisco and VMware are the main companies. So who are all working in a better way to improve this particular field, actually, the NFV. So there are some tools, so that is licensed version tool, not available, the free trial versions tools, but the Cisco and the EVMware. So those two are the main things, are main companies, I can say, industries are working in a better way with respect to NFV. Message Jesse or Micro Focus or Sandfog, and also the ACI Mercury or RS VF AVX services. So there are many companies who are working with respect to NFVs.
Thank you, sir.
Yeah.
So I think we can conclude the session.
Yeah. Thank you very much once again for giving the opportunity. Thank you all.